Hi, good evening everyone. Today we are going to learn the concept of source transformation. Okay, so what is source transformation? Is a practical voltage source. So this is a practical voltage source consisting of an series resistor or SC with a voltage of Vs. So this is a practical voltage source. This practical voltage source can be converted into an practical current source with a current of I amperes and with a shunt resistance of R shunt. So this resistor is called R shunt and the shunt value is equal to series resistor value. And how to find out this current? So actually you know that, so we want to find the current in this branch. So in order to do that, I'm short circuiting this end and I'm going to write down the current I is equal to, how to write down this current? Leaving terminal, current is leaving terminal is Vs minus 0 divided by Vs minus 0 divided by the branch resistance. This is R series. So we got the current. So this is nothing but Vs minus 0 divided by R series resistance. There we have got the current source. This is, we are converting the voltage source into an current source. This transformation is called source transformation. So let's try to understand in one more way. So you can convert this into back into an voltage source, or how to convert. So here you require the voltage, where I'm going to label this as a plus minus. So I require a voltage source in series to an resistor. So already I told this will act as a series resistor, that is equal to which value? Shunt value. And how to write down this voltage? So how to write down this voltage? Let's try to understand some, apply some nodal analysis at node Vs. At this node I'm going to write down. So at this node you can see here current I is equal to current I. So the current I is entering and the current leaving. So here's the same current is leaving. So I can write down this as Vs minus 0 divided by R shunt. So the product of I into R shunt gives the value of voltage. So like this, you can convert a practical current source into voltage source, or a practical voltage source into current source, or a practical current source into voltage source. Then these techniques are called source transformation technique. Let's try to solve a problem for your clarity. So let's try to solve some more problems. So problem number one, convert the following current source into an voltage source. So the problem given is, so this is the current source given to us, and the resistor given is 10 ohm and the current is of 10 amperes. He is asking us to convert this practical current source into an practical voltage source. So how to convert? See here, so I want to find the voltage at this branch. Okay, so I'm going to write down this voltage as some Vx. So I'm going to draw the voltage symbol, which consists of an a series resistor. So the value of this series resistor is same that of the value which is connected in parallel, that is equal to 10 ohm. So now you require these two has to be replaced with an voltage source. So directly we can write down Vx is equal to I into R. I is 10 into R. R is how much? 10. So directly people will claim that this is 100 volts. So you may get doubt, sir, how it is 100? Why you've done the product? So for this, I'm going to design this with the help of an nodal analysis. So applying nodal analysis at the node Vx. So when you apply the nodal analysis, You can see here what are the entering currents. This is entering current, and the same current is leaving. So I can write down 10 amperes is entering, and the same current, how this current is, how many currents are entering, one current is entering. If you want to relabel, the same current is also relabeling, which is nothing but some current Ix. So the leaving current is Ix. So now 10 is equal to Vx. So how to write down the current Ix? Vx minus 0 divided by 10. So now this implies Vx is equal to 10 into 10, which is equal to 100 volts. So the same answer we had already got. So when you are converting a current source into voltage source, just multiply the voltage V is equal to I into R, where I is 10, resistor is 10 ohm, we are going to get 100 volt. This is one procedure. Or if you want to proof, sir, why you done the product, the proof is like this. Apply nodal analysis at node Vx and entering current. Actually, these are in a closed path. So 10 amps is going, and this 10 amps is also can be written as Vx minus 0 by 10. That's how we are getting 100 volts. This is called the first problem. Let's try to solve the next problem. Second problem, convert the following given current source into an voltage source. So here what is given is a voltage source is given to us and connected with a series resistor like this. The voltage source value is 10 volts and resistor is of 5 ohm. So he is asking us convert this, find the equivalent current source. So if you want an current source. So how to find the current source? First draw the diagram of current source. This is the current source and this is the resistor, where this resistor will call it as a shunt resistor. The shunt resistor is equal to series resistor. What is the series resistor value? 5 ohm. So now we want to find the current. So how to find the current in this branch? That's why we are shorting it and we are writing this current as I. So this is the current I. So I can write down, calculate I is equal to, so voltage at this point is 10 volts and this is 0 volts. The current is leaving, and the current is leaving, I can write it as 10 volts minus 0 volts. So plus 10 minus 0 volts divided by branch resistor. Branch resistor is 5 ohm. 5 ones are 5 twos are. So you are going to get the current of 2 amperes. Or directly also you can do it, current I is equal to V by R. So how to get the current? 10 volts minus 0 by R. So this is how we converted a given voltage source into current source. Given voltage source into current source. Let us try to solve one more problem to understand it better. Third problem is find the equivalent current source for the network shown below. So a network is given to us. So this network is like this. We have a resistor and we have a voltage source. We have a resistor and we have a voltage source and we have a resistor, and this is an 1 ohm. This is 10 volts. This is 2 ohms. This is 20 volts. This is 5 ohm. This is 6 volts. So we need to convert this into an equivalent voltage source. So V equivalent we require. Later we'll convert that. So I'm going to draw the equivalent voltage source in series to an resistor. So you can see here the current I is flowing. Okay, so this is positive terminal, negative terminal. Let's try to analyze this network. So current is going, so current is leaving. How to write down? So whenever the current is leaving, what is the leaving polarity we have? Which is nothing but plus V equivalent. Okay, current is leaving. What is the leaving polarity? Plus 10. Current is entering this resistor. Current is leaving. What is the leaving polarity? Minus 20. and current is entering 5 ohm and it is leaving here. What is the amount of voltage? Minus 6 volts is equal to 0. So from here V equivalent we are going to get it as 16 volts. So we got the V equivalent, which is a 16 volts. And what is the resistor between these two branches? You can say one current is same, 1 ohm, 2 ohm, 5 ohm are connected in series. So there's nothing but 1 plus 2 plus 5. So which is ultimately 8 ohms. So this we got a voltage source, but our answer is an current source. So in order to draw that, so you can see here current is flowing like this. What is the leaving polarity? Plus here. Automatically the current source polarity also will be upward direction. And here you are going to get an resistor like this. And this resistor is nothing but a shunt resistor. And the value of the shunt resistor is equal to series resistor. So that is equal to 8 ohms. And we need to find out the current I in this circuit. How to find the current I in this circuit? So current, so how to write down the current? Current I is equal to, so the leaving polarity is 16 volts minus 0 volts, 16 volts minus 0 volts divided by 8. 8 ones are 8 twos are 16. So this current is of 2 amperes and the resistance is 8 ohm. This is how to solve an problem. Let us try to solve one more problem to understand in more detail. So hope you are able to understand. So these three sources replace it with one source. These three resistors are in series, replace it with one resistor. This I applied source transformation. So current I equal to V by R. 16 minus 8 is nothing but directly 2 amps. The resistor which is connected in series here will act as an parallel resistor. That's all. Very simple. Let's try to solve the one more problem. Problem number 4. Obtain the single current source for the network shown below. So a network is given to us like this, shown below. So here a voltage source is given and a resistor is given. And again a source with negative polarities is given like this. This is 5 ohm, this is 6 ohm, this is 18 volts, this is 10 volts. So this is what given to us. We want to reduce this into a current source. Before doing this, let's try to convert each source into an, so this I am marking for your convenience, 1 2. So between 1 and 2 I am going to draw an voltage source. This is a voltage source is given. I am going to draw the current source, and between 1 and 2 I am going to get a resistor. What is the value of the resistor here? So this is a shunt resistor, and what are the resistor you are going to have? The same resistor you are going to get, which is 6 ohm, and between same 1 and 2, I am going to, this is 1 and this is reference node. We are going to have one more current source and one more resistor, and here you can see here the polarity is upward direction. Okay, so now what is the current value? Current I is equal to V by R. V is how much? 18 minus 0 by R. R is how much? 6 ohm. Automatically you are going to get this current as a 3 ohm. So you can see here the positive terminal is there. So I am representing in upward direction. But in this circuit, here you have the positive terminal, then you have to show the arrow mark downward. Okay, so then you have to show the arrow mark in downward direction as indicated here. So I'm showing now the arrow mark as per the source in downward direction, and I want to find the current in this branch. So current I is equal to V by R. What is V? 10 volts minus 0 by 5. So 5 ones are 5 twos are. So this source is of 2 amperes. And what is the shunt resistor? Whatever the resistor is there in series, and this resistor will be duplicating here. This is also equal to 5 ohms, and you are having the terminals like this. So now for this given network, we need to reduce it again. So how to reduce this? You can see here, I want to reduce into an equivalent source. What are the nodes we have? So all these are node 1, node 1, node 2, node 2. So between node 1 and 2, I need to calculate. Let us assume that I want to find out the resultant current I x. You can see here, in order to find the resultant current, apply nodal analysis at node ix. Okay, take this at node 1 directly, node 1. So you can see here how many entering currents are there. So 3 amperes current is entering, and what are the leaving currents? So to this node, this source is entering, and what is the leaving node? 2 amps is leaving, and to this source, what we have to find out is also leaving, which is nothing but Ix. So 3 minus 2 is equal to how much? Ix. So therefore, 1 ampere is equal to Ix. So between 1 and 2, I am going to get an current source with how much magnitude? 1 ampere of this given direction, and we are going to have a shunt resistor. You can see here between 1 and 2. So between this 1 and 2, between this 1 and 2, we are having two resistors are connected in parallel. So that is 6 and 5 are connected in parallel. So when two resistors are connected in parallel, what is the formula you are having? 6 into 5 divided by 6 plus 5. So when you solve it, you are going to get it as a 2.72 ohms. This is one kind of problem. Hope you are able to understand the problem. I converted between the nodes 1 and 2. This is a practical voltage source. I converted into an current source. This is a voltage source. I converted into current source, and for these two current source, I am finding the resultant current by using nodal analysis. I applied entering current is 3 amperes to this node, and leaving current is 1 ampere, and the next leaving is Ix. Therefore I determined the current Ia, and you can see here this 6 and 5 are connected in parallel. So I have done the product of the resistor. I got a 2.72 ohms. This is one category of problem. Let's try to go to the next category of problem. Here, for the circuit shown below, convert into an equivalent voltage source is asked. Very simple to do it. So here going to have a voltage source with an resistor, and again you are having an current source in parallel to an resistor. So the current is of 8 amperes, and the resistor is of 4 ohms. Just try to mark these nodes. This is 1, this is 2 if you want. These both are 1, same. Okay. And now we are having this as 12 amperes, and this is of 6 ohm. Just try to mark this node as some x and this node as y. So now I am going to draw it. This is x, this is 1 and 2, and this is y. So between this x and y, I am going to have a resistor and an voltage source. Between now, what is the voltage source? V is equal to I into R. I is how much? 8 into 4. That's nothing but 32 volts. And the resistor which is in parallel here will be the series here. And coming to the next branch, so V is equal to I into R. So this is nothing but 12 into 6. 12 into 6, this is 72 volts, and this resistor is in parallel and this resistor will be in series. Okay, so from these two resultant we need to find out an single voltage source. So how to find out? So this is nothing but X and one voltage source and a single resistor which is nothing but Y. So you can see here the current is same. I can say that these two resistors are connected in series, which is 6 plus 4, that is equal to 10 ohm, and we need to find out the current in this branch. Okay, already we require this voltage source. So how to find the voltage is, let's try to apply KVL. So this is V equivalent what we require with positive polarity and negative polarity. So current is leaving. When the current is leaving, what is the leaving? Apply KVL inside the loop. So current is leaving. What is the leaving polarity of the voltage? Plus V equivalent, and it is entering, passing like this, and it is leaving. What is the leaving polarity we have? Minus 32 volts, and it is entering into 6 ohm, and it is leaving here. What is the leaving polarity? Minus 72 volts. V equivalent is equal to 32 plus 72, which is 104 volts. So here also we are going to get 104 volts. So we converted the given current sources into voltage source and two voltage source into a single voltage source. This is about source transformation. We can convert a voltage source into current source or a current source into voltage source. When you are converting this into current source, current I is equal to V minus 0 by R, and you want the voltage here, V is equal to I into R. So this will help in solving many problems. So hope the video is useful. If you feel the video is useful, give a like and share to your friends and subscribe to our channel. Hope you understood the concept. Thanking you, yourself.